By the end of the century, it's projected that the Alps here will be more or less without glaciers. I'm Lindsay Nicholson. I'm a glaciologist here at the University of Innsbruck. We do various things on a glacier when we go and do our field work. The work is fundamentally about combining observations, measurements from the field, with numerical simulations and models or theoretical ideas of how all these processes work together. So in the field, we tend to measure aspects of the atmosphere immediately overlying the glacier, maybe with weather stations installed on the glacier, off the glacier, and doing comparisons, looking at the wind direction around the glacier basin, sometimes using balloons or winches to profile the atmosphere. We're also pretty interested in the total change of the glacier itself. So we measure how much snow is falling on it by digging snow pits, the same as people do for avalanche safety, except for we want to measure the whole mass of water that's been accumulated over a given period of time. We might also be interested in the chemistry of that snow that's making it up, what's being deposited from nearby or far away pollutants, and what's being transported and contained in the snow and therefore entering the water system in these headwaters, which are then, it's transported all the way through our water system. And we also might be taking some short, shallow ice cores to look at how the ice itself is forming from the snow, the processes of densification. And in some instances, like I've worked on ice core projects where we look at much deeper ice cores to reconstruct climate histories. And then back in the office, we kind of construct numerical systems of equations that represent how this whole system might be working. And one of the fundamental things we do is we use the field measurements first to stimulate ideas and have observations of what's happening, but then also to be able to collect data to test how well our numerical models are really representing what we hope they are. So we're really lucky here in the glaciology, or the ice and climate unit it's called here at the University of Innsbruck, because we're embedded within an atmospheric science department, which is pretty much unique in the world. To bring those two together so explicitly, and we profit from all the deep atmospheric physics understanding that we bring into the climate modelling we do and the glacier modelling we do. So we're currently kind of expert at the processes that act at the interface between the glaciers and the overlying atmosphere, and that's where my part of the research is focused. But in our team, we have people who specialise on developing numerical models that represent the behaviour of glaciers at a global scale, as well as we have people working developing the latest and the most flexible kinds of climate model that allow us to resolve complex atmospheric processes in ways that we can then project those and events and cyclones and extreme weather events into the future.